In this video, we're going to be looking at how we can find probability using tree diagrams. Now, what exactly are tree diagrams? Now, a tree diagram is a diagram that basically just enables us to visualize and see our probability space. And it helps us create our sample space. Right? So let's get into it with a question. So our first question states this: find the probability of having heads when flipping a fair coin twice. So what can we get if we were to flip a fair coin? We can either get heads or you can get tails. So let's visualize this. In our first flip, say we're going to start with our coin toss. And from our coin toss, we can get either a head, which will represent with H, or a tail, which will represent with T. And on our second coin toss, from this head, we can either get a head or a tail. And from this tail, we can either get a head or a tail. So this right here on the circle in red, this was my results for my first toss, this right there. And my second toss will be right here. Now from this tree diagram, we can create a sample space. Our sample space is going to have all of the possible combinations that we can get from this. So we can have head and head, right? That can happen. So we're going to put head as one of the options. Our next option can be head and tails. So we can have a head and we can have a tails. So now we can also have a tail and a head. We can also have a tail and a tail. So these are our possible combinations. So in total, there are 4 possibilities. Now, the question asks us to find the probability of having heads when flipping a fair coin twice. So we're just looking at the probability of head in this case. So we're going to write P of H. What is the probability of getting heads? So we're going to look over here, so where we can find at least one head. So in this case, also it is important to note that having heads, because we should be able to specify this in the question, right? Not just having heads, but of having at least one head, right? At least one head. Okay? They can ask different things. They can be like, okay, what is the probability of having 2 heads? What is the probability of having 3 heads, right? But for this question, we're going to specify at least one head. So in this case, the probability of head is going to be, I'll write this actually a little better, right? So we shouldn't say probability, we should say probability of at least one head. There we go. One head. Now this is going to be equal to how many of that? Our sample space has a total size of 1, 2, 3, 4. And out of it, 1, 2, 3 have at least one head. So therefore, this is the probability, which can also be represented as 75%. Okay? Now, what if the question stated this? I want you guys to try this on your own, right? The probability that we have at least 2 heads. I want you guys to give that a go on your own. You can pause the video and try it out on your own. Now let's solve this question. So the question asks the probability for at least 2 heads. So in this case, we have 2 heads circled right here, and that's the only place in our set where we have 2 heads. So therefore, it's going to be equal to 1 over 4, which is equal to 0.25, which again is going to give us 25%. Now, our final question asks us, what is the probability for no heads? Again, you can pause the video and try it yourself. So the answer to this would basically be, we're going to be looking for somewhere in our set where there's no heads. And the only place we can find it is here where we have 2 tails. So therefore that is going to give us 1 over 4. So just like before, we're going to get 0.25, which is going to give us 25%. So that's it. I hope this video helped. Have a good day.